I'm going to talk about something that is a semi-preprocessor, which is a term that I had to invent to describe how it works. And that some of the things that it understands, they look like ASCII art in two-dimensional ASCII art. Let me start by the prehistory of this. When I was typesetting my master's thesis that was about categorical semantics, I had to do several types of diagrams, and some of the diagrams were like this, like natural deduction and similar things. In Portuguese, this is dedução natural. So that's why the name is dead nut. And my thesis had lots of diagrams like this. In the beginning, I used a package called proof.style to typeset them, but the code for each diagram was so difficult to visualize, so opaque, that I had to keep a 2D ASCII art version of each diagram in comments so that I wouldn't get lost. For example, this is the code for proof.style. I can't understand it without thinking a lot, so I would put that in comments, and that would help me to debug the proof.style code. And this thing generates this. And then at one point, I realized that writing code for proof.style was boring, and that it was more fun to automate the boring part. So I changed the syntax of the 2D trees a bit. I made it more rigid and more easy to parse. And I wrote a parser in Icon, which was one of my favorite languages at the time. My other two favorite languages at the time were TCL and Forth. And so I wrote this parser. It was just 100 lines long that understood it. And the parser would understand a thing like this and generate this. And note that below the tree, there's a name tag here. We can interpret this as an arrow pointing up. So this says that this tree is called foo, and this thing generates this code that defines a deduction called foo. And this is a trick to use another namespace for the names of deductions and to let me use weird characters in their names. And the trick was that my deadnut.icon would only look for trees in lines that started like this. The other comments would be totally ignored by it. So TeX would ignore these things because they were comments, and deadnut.icon was just looking for some kinds of comments to parse trees in them. And originally, this string would save these definitions here in another file, so that I could have something like this. This is a specification for a tree. After the tree is defined, I can say /dead foo, and I would get the ugly code here, but it's hidden. And the ugly code is saved in another file. In this case, it was called myfile.auto.dnt. So I wouldn't need to look at the ugly code. It was saved elsewhere. And running the preprocessor on myfile.tex would generate the file myfile.auto.dnt. And this first version only understood one kind of head. The heads were these special comments. The lines that started with %: would be scanned for deduction trees. And then, of course, there were deadnut2 and deadnut3, but they're not relevant. At one point, I wrote something that was called deadnut4.lua, that was written in Lua, of course, and it understood many more other kinds of heads. It understood trees, it understood Lua code, and it understood diagrams specified in a thought-based language that I'm going to show. And the idea is that as I could put Lua code anywhere in the program, I could add new things, I could change new things, I could add debug code, all kinds of things, and I could do that dynamically. And ignore this. This is just a technicality, OK? So this is a first example of the language for diagrams. I put that in a very small font to mean you do not need to understand this now, OK? I'm going to use a simpler example later. But this is an example of a diagram that is very complex. But it was very easy to visualize and to debug in this language is this is just 40 lines of comments in my extension language, and it generated this. And one of the ideas that I took from Forth is that in Forth we have some words that can, in Forth everything was so accessible that no variables are hidden, all variables are accessible from anywhere. You can change all variables, and you can change the behavior of the parser. So you can have words that change the way that the parsing works. You can have a word here that advances the parser pointer, and it treats this thing here by itself. I call this words that eat text. So this is an example that is easy to understand. This example here generates this diagram. Note that this is a two-dimensional version of this. I use the prefix 2dx and 2d to tell the parser that this thing specifies a two-dimensional version of the diagram. And here I join the nodes using arrows. Now let me explain very quickly how this thing works. By the way, I wrote, this is a descendant of an article that I wrote in a book called Lua Gems that was called Bootstrapping a Forth in 40 Lines of Lua Code. And this article already had the idea of implementing words that eat the next word or that eat the rest of the line. So I highlighted some words here in red, and the words in red, they eat text. The words 2d and 2dx, they eat all the rest of the line and process that as a grid. And they use this to define some nodes with coordinates. This word here eats the next two words, and it changes the arrow that is at the top of the stack. And this thing is also, it eats three words. But let me explain this with other colors, okay? I painted the nodes in blue. So this specification of the grid here creates a node called LA with these coordinates, a node called LA with these coordinates, and so on. And it ignores the other things. So the other things are just for me. The things in purple are the coordinates. Yeah, and the words in green are arrows that join the last two nodes on the stack. I cannot explain that language right now. I added some stacks here, some slides here that I'm not going to explain, but if someone is going to look at the slides on the site, this explains a lot of things. So this is one of the slides that I'm going to skip. It explains several technicalities for people who want to use the language. OK, so let me start talking about the NAT6, which is a semi-preprocessor. Remember that the NAT4 is a real preprocessor in the sense that it takes a file, foo.tex, and it generates another file. It processes it all at once, and it generates another file called foo.auto.dnt, and it runs before LaTeX. In the NAT6, the Lua code that processes the lines with heads like this, it pretends to run at the same time as TeX. It's not exactly that it does that, but it's, in fact, there are some synchronization points. Remember that each tree specified in a block of lines like this, it generates a def-det that generates the code for a deduction. Each diagram in a block of lines like this generates a def-diag. And the new thing is that \pu means process all pending heads, like this, this, and this, until the current line. And then send the definitions to LaTeX, sent by using output or something like this. I forgot the name now, sorry. But instead of saving the definitions in a separate file, it sends the definitions straight to LaTeX. Let me explain this idea because this is the main topic of this talk. this idea is implementing a data structure, a very simple data structure that I call blocks. And each block has an I and a J field. Let's say the starting line and the ending line of the block. So in this example here, we have a two-dimensional diagram here. We have a tree here. This thing is a block of %d lines. This thing is a block of %colon lines. This block is in lines 1 to 10. Then we have a PU here. Anyway, sorry, let me take a better example. Here, this is an enlargement of the thing that I showed before, but with more detail. In the beginning, we have a TeX file. In this small example here, it's a block that starts on line 1 and ends at line 24. And this block here says that we are currently at line 1. We haven't processed anything yet. So when LaTeX is processing this, it reaches a PU at this point, which is in line 12. And then Lua runs this, process until line 12, which means process everything from the last thing that was processed in line 1 to this position here. So it processes everything from lines 1 to 11. And there's a block here. And this ends up running process block with this head here, and starting on line 1 and ending in line 10. And then this thing is going to run the processor for diagrams. And it's going to produce some TeX code, that a function that I wrote called output. It takes the TeX code and it sends that to LaTeX. And then it changes the end line to this position here. And then the same thing happens again at the second PU. When we run the second PU, the end line is here, and it processes everything from this point to this point. So this is how the semi-preprocessor works. Just a small comment about how to download and test this. At one point, I tried to keep a TGZ package or a Git repository of the .NET 6, but it didn't work very well for several reasons. Then I gave up. And now if you run something like this in a shell, note that this is something that is on my site. There's an article about planar heighting algebras for children. So this thing here is familiar. Is a URL for a PDF. And if you change the extension to TGZ, and if you download this and you unpack this, you're going to have all the files for generating the PDF, which means that you have not only the body of the text, but also all the dependencies and a full copy of the right version of the .NET 6. And if you go to the homepage of the .NET 6, it's going to point to several TGZs like this. Some of them very simple and some of them very complex. So this is how I'm doing now that I gave up having a Git repository of this. This seems more simple right now. I mentioned that this thing is very extensible. Usually, sometimes we want to extend it by adding new heads. For example, at one point I had a friend who was working on Frege's work, or those diagrams for the 19th century, for the big Riefschrift. And the TeX code for typesetting, that was very ugly, so I wrote an extension in which we could edit that in two-dimensional comments. He didn't get very interested, but anyway, I tried. But it's very easy to implement new heads, and this is a very simple example that I use in these slides. I realized that I was going to use verbatim mode a lot, and I probably would like to have some extensions to verbatim, and it was easier to create my own mode. So if I run this register head, this head here, %v, with this table here, the important thing is that this table has an action which says what to do with the block of %v's. And this action is very simple. just take the output, or just take the block. This function here returns the initial line, the ending line, and the table of lines, and put that in a global variable. And in this example, in the beginning, I didn't know what I wanted to do with my verbatim mode, so I just put that in a global variable so that I could write more and more Lua functions to process that in weird ways. So suppose that you want to understand this and you want to hack this, and hacking usually consists in 3 stages. The first stage is that you want to read things, which means you want to understand the docs, the documentation, the data structures, and the code. The second stage is that you want to make non-trivial tests, and you want to dump data structures. You want to do some tests, and you want to see what data structures are created. And the third stage is, I call it writing, which is you want to implement new things like new extensions or things like that. And here's a bit about how to do one, which I suppose that is the first step for anyone interested in doing this. Even if you don't use Emacs, it is trivial to learn a tiny bit of a package called EEV that is in this place here. And then we can run something that I call e-pitch blocks that are in comments in Lua source files. This is a comment block in one of the files of the NAT6. So there's real code here, and this is this comment here that is ignored by Lua. And if you're running Emacs with EEV and you put the cursor at this point here, and you type F8 several times, the first 3 F8s are going to process these lines here, and they're going to split the Emacs windows, the Emacs frame into windows, the left window with the source and the right window with the terminal running Lua. And when you type F8 here, Emacs is going to send these lines to the terminal running Lua as if the user was typing them. Oh no. This is unreadable, sorry. Anyway, the idea is that I was making an experiment at some point, and I can use F8. I can record the experiment and use F8s to play back my experiment, the log of my experiment. I'll try to explain this, even if it's unreadable, okay? Here is a screenshot. Here is the Lua code. And I just typed F8 from this point to this point. So Emacs has created a Lua interpreter here. Emacs uses different colors for the Lua prompt, for the thing that I sent, and the Lua output. So it's easy to see that these lines here, unreadable, become this, and that the last line prints the content of the arrow of the table nodes and shows it here. And in this example here, I'm just using a terminal running Lua to make some tests. In the next example, also unreadable, sorry, but I'm going to run LuaLaTeX, stop the TeX interpreter at some point at this line here that invokes the Lua REPL from a guy called Rob Hoyles. And so this is not the standard Lua interpreter. This is a Lua interpreter written in Lua. And then I'm going to send some comments here and some commands here. And these commands here, they access a data structure that is available at this point, which is the contents of the box number 0 that I created here. And it inspects the data structure. So this is a way to explore the data structures of LuaLaTeX. And for years, I couldn't understand this. I found the documentation very hard, but by making these experiments, things became a bit more clear. How much time do I have?
10 minutes.
Really? Wow. So I went very fast. Anyway, I'll think later about what to do. I decided to end this set of slides, not with the thanks, but with a hey, because as I said, I tried to document and to package the .6, but I was getting very little feedback and very bad feedback. People were always saying, "You're writing things are wrong. I cannot understand. I cannot test this on my machines," and such things. So I gave up, and I decided to say very explicitly, I don't have a mental image of who I'm writing for. So please explain who you are so that I can make documentation that is useful to you. And so I didn't find anyone who was interested in this and who knew enough about LuaLaTeX for becoming interested in this. So if you are interested in doing that, using that in any way, either for making diagrams with the packages that already exist, or for creating extensions, please let's chat. And maybe you have some big diagram that, this is common in category theory. People have big diagrams that they took a full day to typeset, and I usually can retypeset the diagrams using this in 20 minutes. And maybe you need some weird extension or whatever. Anyway, let's chat and let's see what happens.
Any questions? If not, we'll adjourn. Oh, yeah.
You go first, then. Hi, Eduardo. First of all, congratulations for your package. I thought it very, very, very interesting. I really like this conversion facility. It really helps. It's not actually a question, but I like to tell you that I sympathize what you wrote in this last slide, because it's awfully difficult to write documentation, because I've just written documentation for my tool, and I know how difficult it is, because everything is inside our head. We know what we're talking about, so everything is so clear to us. But when we try to expose our thoughts to other people, perhaps something is not too clear. So I'll ask something. I would like to ask if you plan to extend your conversion utility to let's say it is still a plain format. You exploit the comments. The comments. I was wondering if you would extend it to accept other formats, like, for example, I will not say too much verbose format like XML, but perhaps YAML or other plain format that's not too verbose as XML, but it's still a plain format.
It's easy to do. At any point in the, remember that well, I didn't show any examples in which I used lines like this. But you can you can put a line like this anywhere in your code, or you can use a direct Lua, and then you have access to all your TeX document and all the individual lines. So you can even access TeX code that is already being processed by TeX. So you do not need to only process the lines that are considered as comments.
Thank you. So, my question's gone away. So anyone else?
Yeah, can you put again the one of the first examples that was intended for us to? Yeah, that one. No, that was intended for us to understand. This one. What's the parentheses part? Because it looks like redundant with the.
Yeah, the thing is that when we do that, we put a lot of garbage in the stack. The first two open parentheses, it stores the depth of the stack at this point, and when we get this, it drops everything from the stack until we reach the depth that we had here. So it is just for dropping garbage.
But I have to write that because it.
No, it's optional.
Oh, okay. I don't have to write that. I can write just the upper part.
Mm-hmm.
Oh. Because I thought I would have to write that,
No,
all that,
sorry.
and then it was not very
Yeah,
clear.
and I
that-
didn't explain that. Sorry. Oh no, sorry. I did explain that in the line that I said I'm not going to explain this. Yeah. So the explanation is here.
No, but my question was not exactly. My question was whether we need that. That's the main
Yeah.
part.
Then the answer is you
Not
don't.
what if we don't have to write it, it doesn't matter what it does. I was.
Any more questions?
Any more? Well, thank you again.
Thanks a lot.
We adjourn for a coffee break now over here at